Hello everyone, I'm Sebastian Y and this is Foundations of Economics. In this video we're going to talk about how changing the size of a tax affects the tax revenue and deadweight loss. We'll finish up by thinking about how elasticity affects welfare with the tax. In the last video we talked about how to calculate deadweight loss and tax revenue. We started out with an example where the tax size was 2. What happened here was we got a tax revenue that looked like this, and a deadweight loss that looked like this. We calculated those areas to get a tax revenue of 30 and a deadweight loss of 5. Since we already did those in the last video, I won't do the detailed calculations. We'll now see what happens if we decide to double the tax from 2 to 4. Our new tax wedge will have a length of 4 and will fit in right here, which makes our tax revenue this box right here. This will have an area of 10 times 4, which is 40. You can see that's gone up from when the tax was 2. And our deadweight loss will be this whole triangle here. That's going to have an area of base of 4 times a height of 10. Divide that by 2, we get 20. Comparing this to the deadweight loss from when the tax was 2, this has quadrupled. This is a general result. When the tax doubles, the deadweight loss will more than double. When we have linear supply and demand like this, it's going to quadruple. The reason for that is that when we double the size of the tax, we are doubling the base of the triangle, but we are also doubling the height of the triangle. So the area is going to be 4 times. Let's continue increasing the tax, this time all the way up to 6, which is 3 times the original. Drawing in the new tax wedge, it's going to come in right here. And so our tax revenue will be this box right here. And our deadweight loss is going to be this triangle right here. Calculating the tax revenue, this time we have 6 times 5, which is 30. And for the deadweight loss, we have 6 times 20 minus 5, which is 15, divided by 2, which is 45. What we notice about this is that the tax revenue is starting to come down, but the deadweight loss continues to increase. Now our tax is 3 times the original, but the deadweight loss is 9 times the original. Again, this is because we have tripled both the base and the height of the triangle. If we were to continue this on and increase the tax to 8, this will shrink the market all the way down to 0 because the tax wedge will fit in all the way across here at 0. Here the tax is so large that it completely shut the market down. Since no units are being transacted, the tax revenue goes all the way to 0, and the deadweight loss is going to be the full 80, which is the total surplus we would have had with no tax. We can actually add one more case where the tax is 0. When there's no tax, of course, the tax revenue is 0, as well as the deadweight loss. Let's think about the relationship between the size of the tax and the tax revenue. We can see that there is a somewhat counterintuitive result here where initially the tax revenue increases as the tax size increases, but eventually it reaches a maximum and starts to drop back down. The reason for this is that the tax can eventually get so large that the size of the market drastically shrinks, which actually decreases the total tax revenue. Let's graph these. When we have a tax of 0, we have a revenue of 0. When we have a tax of 2, we have revenue of 30. A tax of 4, we have a revenue of 40. Tax of 6, we have 30. And when we get to 8, it drops back down to 0 again. We can sketch in a curve here. what we have is a parabola. The relationship between tax size and tax revenue is called the Laffer curve, named after the economist Arthur Laffer. Back in the 1980s, Laffer argued that the United States was actually on the right-hand side of the Laffer curve, and that lowering taxes would actually increase the government's revenue. This drove a lot of the policies of Ronald Reagan, which were known as supply-side economics. Although it is theoretically possible to be on that side of the Laffer curve, economists generally agree now that that was not the case back then. We will now think about the relationship between tax size and deadweight loss by graphing that. Of course, when we have a tax of 0, there's going to be no deadweight loss. At 2, we get 5. At 4, we get 20. At 6, we get 45. And at 8, we get the full 80. Connecting these up, we get a curve that is, like the Laffer curve, a parabola, but this time it's only the right-hand side of a parabola. There's a quadratic relationship between tax size and deadweight loss, meaning that as tax size increases, deadweight loss increases faster, which is exactly what we see in the numbers. This curve does not have a special name like the Laffer curve. The last thing that I want to talk about is the relationship between taxes and elasticity. I'm drawing in two different supply and demand graphs. I'm going to draw a demand curve on both of them that looks roughly the same. In the left-hand graph, I'm going to draw a supply curve that is relatively inelastic. That is, it's pretty steep. In the other one, I'm going to draw a supply curve that's relatively flat or elastic. Back when we initially talked about taxes, we talked about the fact that elasticity affects which side of the market ends up paying more of the tax. Elasticity also has an impact on deadweight loss. I'm going to draw in a tax wedge on both of these graphs. I'm going to try to make these tax wedges as similar as possible. So these two black lines are roughly the same length. The deadweight loss we get when the supply curve is highly inelastic is this skinny triangle right here, but when supply is relatively elastic, the deadweight loss is this much larger triangle right here. So when either curve, the demand or the supply, is more elastic, ceteris paribus, the deadweight loss is going to be larger. The reason for that is that when people in the market are elastic, that means that they are highly responsive to changes in the price. Since taxes change the effective price for both the buyers and the sellers, if, for example, our sellers are highly responsive to those price changes, then the market is going to shrink a lot. If they're not very responsive to price changes, then the market doesn't shrink very much. We can see that on our graph where the equilibrium quantity compared with the quantity with the tax is almost the same in the left-hand graph, but is greatly changed in the right-hand graph. This distance versus this distance. This means that when the government is thinking about putting a tax on a market, they need to be thinking very carefully about the elasticity. This also has a big impact on tax revenue, which is going to be about this box with the inelastic supply and this box with the elastic supply. And you can see that, again, because of the shrinking size of the market, the tax revenue is going to be much bigger in this one than over here in this one. The federal government's largest source of income is taxes on the labor market, that is, income taxes. As such, it's a very important question for the government to think about how high do they want to make income taxes. We can think about that issue using these graphs in front of us. Some workers might have an inelastic supply curve like the graph on the left. This might be the case in households with only a single wage earner. Even if taxes increase and they're taking home less of their income, they really don't have much of a choice but to continue working. However, if a household has multiple income earners, they might be more elastic with their labor supply. If taxes increase, then people in those households might choose to transfer some of their labor to the home. The overall labor supply elasticity is a matter of ongoing debate, and there continues to be quite a lot of research on this issue. As we've seen, disagreement on this issue can also lead to disagreement in policy recommendations. Economists who believe the labor supply to be overall less elastic might advocate for higher taxes, whereas an economist who believes the labor supply to be highly elastic would tend to advocate against higher taxes. Regardless of the elasticity, the government has an important job to do in determining how high taxes should be. Taxes are used to fund important government programs, and the government needs to weigh the potential deadweight loss caused by the taxes that fund those programs against the benefits that those programs provide. And that is everything that we are going to cover relating to taxes and welfare. If you have any questions, feel free to let me know. Thanks for watching.